You heard how she was. When?
So, relative to 6 questions.
I didn't say anything was wrong.
I got a burger and a salad. And you get the so bad. I already did it. What? Would you stop me really quick? I'm so excited for Monday. Why? Go to for 11. Kayla coming. Okay, not so much now. That was too much. Bro, where does it say multiple elections? What's your favorite food? Okay, but you were trying to park it in the road. I told you it was bad. Sorry, but I don't drive. I have your license. God, Rick Reynolds money now. I was on my back. You're like, no.
This from the very beginning of the chapter. So these are like prerequisite skills. I wanted to remind you to do percentages. It's part over whole. That's going to be important for today's probability problems, part over whole. And when you're asked about percentages, the is over of, putting the is number over the of number, and the percent over 100 is always been a great strategy when you're setting them up. So you put the is up top, the of down below, the over 100. Alright, so of is 30, is 6, we don't know the percent, the p goes over 100. Of is 25, what number is, we don't know the is, 68 is the p over 100.
Why are you laughing?
Darley, what's 68 times 25?
Me? That's a big number.
Yeah, what's 20, 68
It's
divided by
1700. That's too much now. Wait, what kilo? Which means that it's 17. I'm gonna do it for you.
Alright, the 86 is the 34.4. We don't know the P. 100. What did we get for the last one, Riley? Did you do number 3? Which one? What did you get? 40? Even.
Good job.
Alright, everybody remembering that?
Yeah.
Backbone problems are the 2 or 3 step process. Alright, I'm gonna move on. Alright, two-way tables. So, you'll be asked to create a two-way table in today's assignment. Does this look familiar to any of you?
No.
Which is wild because right now in Algebra 1 they're learning these.
That is bullshit.
So when they made the new curriculum, I think they just boomed it into Algebra 2 without even really thinking about, well, you know what? They never even really saw it before. But they're like assuming this is a prerequisite because next year, well, maybe Algebra 1's learning it this year, but long story short, this is a two-way table. So, this is a survey asking males and females how many languages they're fluent in. Read the two-way table and interpret it. So, when you do a survey, if it's random, you really don't know how many people are going to respond. True surveys, you can't make people respond. They might answer, if they're getting paid, they might answer a certain way. If they're not getting paid, they might be angry about it, things like that. So there's a lot of surveys out there that have to be voluntarily answered to get like true, honest responses. So like on this one, it was a different number of men than women that answered, and that's going to happen a lot on real surveys. We need to figure out what we think the number 22 means. So it's really like kind of a point of intersection. So I look, it's in the, for the horizontal, it's referring to the male column, and for the vertical, it's 2 or more. So of the people surveyed, 22 male responders speak 2 or more languages. Okay, so I'll pause and I'll give you a moment to identify what you think 106 and 187 is. Okay, Lewinsky, what'd you say about 106? Responding. Total males and 187. What'd you say about 187, Mariana? Yeah, the total people that responded. 106 is just the male column, and right here is the intersection of male and female.
How many languages do you speak in total?
Fluently, only one, but I'm pretty good at Spanish. I know a lot.
Can you say something in Spanish?
No, let's focus. Alright guys, I want to take some time to go through yesterday's assignment.
Okay.
Alright, that we have 33 have a sum that is not 4 out of 36 possible. Again, this is part over whole, kind of the theme here. 92% have a sum that is not 4. And then how many have a sum greater than 5? Why is it 13 out of 18? 26 out of 36 has been reduced to 13 out of 18. 72% for letter B. A lot of people got that one right, right? Okay. Number 8 just was harder than it. It looked harder than it really was. We didn't have to do anything but count. $20 are not at least 15. So 100 minus 20 means 80 are over 15. 26 are 25 to 45 years old. So 100 minus 26 means 74 are not. So that's just straight up. That wasn't anything tricky. There wasn't a whole lot of thought. You had to put into thinking about combinations or anything. Just reading the circle graph. In number 9, they did a probability saying that there was 3 possible outcomes. But really, there's 4 possible outcomes. If I answer the first question correct, the second one could be correct or wrong. If I answer the first question wrong, the second one could be correct or wrong. So there's 4 possible outcomes. So this probability isn't 1/3. It should be 1 out of 4. This one, they said that there was 4 numbers.
Good morning, faculty, staff, and students. Teachers, please pardon the interruption, but at this time, please release all juniors and only juniors to report to the career fair in the gymnasium. Thank you.
I was wondering what they can include that in I thought they used to do like 8s, but I guess this is too many people. Anyway, so they were saying 27 out of 30 numbers are greater than 4, which isn't true. 26 out of 30 are. So in their fraction, they were including the number 4, and there's actually 26 numbers that are greater than 4. So instead of 9 out of 10, it should be 13 out of 15. Alright, number 11. This was the longest question. So the area of the whole thing was 324. Did anybody even attempt that? 324 area of whole thing. Area of the yellow circle was pi r squared. 9 squared is 81. So the area of the yellow circle is 81 pi. Anybody get that? Okay. The white square, 6 by 6, 36. The triangles, well, all the way across is 18. This is 6, so each of these are 6. So the height is 6. Also, the base is 6. Area of a triangle is 1/2 base times height. So the green triangles were 18 each. So we have to find the yellow, but we have to take out the green and the white. So 81 pi is yellow, minus 36 for the white, minus 18 for a triangle, and 18 for a triangle is about 182 square inches is yellow. So the probability of being in yellow is the yellow over the entire thing, which is the 324. You got a 56% chance of landing in yellow. I feel like you could have done something like that in geometry. Does that look like a geometry question?
Yeah.
This doesn't even feel to me like an algebra 2 question. This one as well. I know you probably looked at it and thought I had no idea, but guys, you do. You know how to do this. If you drop your earbuds over this whole thing, well, that's 0.1, 0.4 is 0.5. It's 0.7 total, 0.7 miles. You could have dropped your earbuds on. What's the likelihood they landed on Cherry Street? 0.2 over 0.7. Part over whole. 29% shot that they ended up on Cherry Street. Now that you see it, does it seem just fine? Did anybody get it on your own? That's so good.
I accidentally put 2 for 4 instead of 3 for 4, and that's the whole thing up.
Oh, but you did on the process.
Yeah.
You forget this whole thing is because SAT practice. There are probability questions on the SAT, and so many times we skip probability. In fact, I haven't covered it since before 2020 because there just hasn't been time, but I'm making it work now. All right. So experimental probability is actually rolling a dice. In theory, when you roll a dice, you got a 1 out of 6 shot of getting any number. Okay, you have a 1 out of 6 shot of getting a 5, 1 out of 6 shot of getting a 3. The theoretically probability of any number is 1 out of 6. Okay, but this is what really happened when the dice was rolled 60 times. Technically, if it should be 1 out of 6, if you're going to roll it 60 times, you should have gotten each number 10 times. 10 out of 60 is the same theoretical probability as 1 out of 6. So which number was successful in matching the theory? 4. 4 was landed on 10 times. I mean, 6 was an overachiever. 6 came up 12 times. You want to bet on 6. 5 only came out 6 times. So this one really didn't land as much as it should. What if the dice is weighted funny, right? Like, how do we even know that it's really 1 out of 6? That's it.
And since the guy who runs the table is only who touches it, no one would know.
No one would know.
This is stupid.
Seems to me to be like really chance to make money. Okay, so anyway, 4 was rolled correctly. Same concept here, guys. All right. If there's 5 colors of marble and you're picking a marble, every color has a 1 out of 5 shot of getting picked. In theory, every marble should have been picked 1/5 times. 5 marbles, pick 1, 1/5. So if I did it 30 times, what is 1/5 of 30? 6. Every marble should have been picked 6 times. Which one was? Black was. But the words say which one is greater. So both red and blue were picked more than they were supposed to be. They were picked 8 and 9 times, which is higher than what they should have been in theory. The last one is the easiest one. This goes way back. How many total stone winners? 26 artifacts. How many of them were pottery? 7. 7 out of 26. 27% chance for your artifact was a pottery artifact.
Are you gonna want to like have us put these answers in complete sentences?
Yeah. Okay, so now I have a classwork question for you.
I'm sorry, guys.
Actually, Alright, good. I just have 2 of these. I just want to practice one of those questions. So read this and come up with an answer. And I will come around and give you credit for that assignment.
Why do you like? Because I'm trying to write you out. There are 10 mice. Wait, say mice. Probably. Yeah, yeah. I live. Oh, and then go. What's wrong with that? There's one H.
I guess that's just what they like.
Alright. Take one mouse and select it at random. What is it theoretical? Probability. That was 110.
How many did you guys try?
I did 3.
Is this the homework by the way?
I did 3.
Oh, you did 3?
I just 1 out of 10.
I tried the front ones and a few of the back ones, and then
Guys, these are good challenge questions for your
Why? Why are you so rude, dude? Yeah, whatever. It's right. Oh, what did you? I did.
Wait, I didn't even know the area one. I got all of them. I literally blinded. How many did you try? Went with it? Yeah, went with it. Alright. Alright guys, there's a scientist studying the nutrition of mice, and each one is selected. There's 10 mice. What's the probability in theory that mice A will be selected to be weighed? 1 out of 10. A 10% chance that each mice will be selected each week.
One more. Oh, there's one more.
Alright, so this is what really happened during the experiment.
Oh, poor A. 40 weeks. I was not J.
The experiment goes on for 40 weeks. Do mice live that long?
Oh, heck no.
Which mice were weighed according to the theoretical probability?
You can fix it. Which mice are weighed according to the theoretical probability?
So it's supposed to be 110. How many times should they be weighed out of 40? 4 times they should have each gotten selected. Mouse B was selected 4 times, and so was mouse I. What happened to J?
It died.
It didn't make it.
Not died.
So I
There you
think
go, hiding.
for like I shouldn't speak. Never mind, I shouldn't even say it. I was gonna say like for experimental like injections and things or exposure to bad experiences or good experiences. I think that they do kind of they make it random. So where every participant in experiment wouldn't experience all of the same numbers. And then a lot of times scientists they randomize it to themselves, so they don't know until the end. Like they want to be able to see changes or patterns without already knowing which ones are getting picked. So they keep it random even to their own knowledge until the end. Anyway, DI. Okay. Here's our assignment. I'm not even giving you guys any notes on the set section. I'm just gonna have you jump right in and try to draw them.
I'm lost. I think it's in the middle, miss. There was like.
There it is. It's page 761. It's probably spanning 3 pages.
Oh, it's on the phone. It has pictures.
It's chapter 8.2.
I do have pictures. Oh.
Alright, so I went through this section and I don't think that the muttings in the book are helpful. I think they're more confusing, but I'd love for you to, read through maybe a quick with you. I know you said it very quick with me, so really I think if we just use reading comprehension and critical thinking, we can apply different strategies to each one of these questions to try to figure them out. It's not a systematic approach like maybe a common denominator is. It's more of a thought process. And did you know that all of semester 2 and ACE Math 1 is probability? So this is a really good warm up.
Why did you get rid of probability and statistics?
Is it AP statistics is still a thing? Is it not?
Not at this level.
Oh, no. I think because of ACE Math 2 is a lot like that. I think because it's incorporated in the ACE Math courses.
Oh,
So it was a conflict. Like the same students couldn't take both. Alright, so our first 2 questions we have to go back to understanding outcomes. But they limit the number of outcomes we have to consider because of the way they're combining things. This section is more on combinations, I think it's called. Really fun. It's just on 2-way tables. I'm gonna do the evens, so I'm gonna do number 2. The assignment? Oh, conditional probability. So this is the probabilities that we were doing in the first section, but they're gonna give us certain conditions that we have to take into account. So I'm gonna go through. I'm gonna do 2 and 4 and 18. I'm gonna do the even problems in class. Number 2. A movie complex is showing 3 action films. They're different movies. Also 3 comedies for the people who enjoy life. You randomly select 2 films to watch. Find the probability that you select a comedy second, given that you select a comedy first. So that given is what's going to shorten possibilities. It's going to shorten the list of outcomes. So that means for our first bit, if we do a tree diagram, we have to watch a comedy first. So I'm either gonna do C1, C2, or C3 first. And then I have to think of all the possibilities that I could watch second. So if I saw the first comedy first, maybe second I walked into Action 1 or Action 2 or the Action 3 theater. Or maybe I did end up with another comedy 2 or comedy 3. So this is all the possible combinations if I watched the first comedy first and I randomly picked a second movie. Action 1, Action 2, Action 3, C1, C3, Action 1, Action 2, Action 3, C1, C2. So in total, the total outcomes if I have to see a comedy first is 15. There's 15 total combinations if I watch a comedy first. My question is, what's the probability that I also get a comedy second? Yeah. So how many show a comedy second? Well, there's 2. So these 2 was a comedy first and a comedy second. These 2 was a comedy first and a comedy second. And these 2 were a comedy first and a comedy second. So 6. So now my probability is part over whole, 6 over 15. 6 combinations out of the 15 options were both comedies. Okay, calculator up, 40%. So I think this is actually easier than the first chapter, especially because we've already been talking about it 2 days. Now I'm going to jump to number 4. Here's my table of cyclones and hurricanes. Find the probability. Alright, the symbols here, and this is where I could have maybe given you some notes about these symbols, but I thought just applying it is the most clear. This is the probability that there was a hurricane in the northern hemisphere. So the concept of the northern hemisphere takes priority. We're not saying the probability that there was a hurricane at all. We're saying specifically of all the storms in the northern hemisphere, what percentage were hurricanes? So go ahead and try it. how many storms happened there? Did you guys add up the total?
46%.
Oh, 40.
If 379 divided by 821.
And 47% for.
So the total storms in the northern hemisphere we have to add up. There was 821 total. So that was the whole data on the northern hemisphere. We're asking specifically about hurricanes. So that's 379 over 821. 46% of the reported storms were hurricanes. Oh, well, the cyclones during hurricane season. So this hurricane in the southern hemisphere, this over Ukraine.
But they called something else when they were down there. Did they stand on it?
I think those is still the, I think the definition of hurricane is Atlantic Ocean.
Yeah, I think it's Atlantic and Pacific. That's the difference.
Yeah,
They call them typhoons in the Pacific.
so I think south of the equator is still Atlantic Ocean and we still call those hurricanes. Alright, so now specifically in the southern, this is saying of all the hurricanes, how many happened in the southern hemisphere? You see how I'm looking at that number second? Of all the hurricanes, how many were south? That's what that sum means. So now we need total hurricanes. Good, you did some? Or did you do all the south only the hurricanes?
Yeah, just add up all the storms in the southern hemisphere.
Are you just adding the hurricanes?
I got 47%.
This is 904 total hurricanes. Yeah. And 300, and 525. Wow, so there's more in the south. Yes, 50.
Oh, yeah, you're right.
You hear the difference? And it doesn't come quick. It doesn't come easy. The second thing listed is what you have to total. So for the first problem, we totaled this column. But for the second problem, we totaled the hurricane column. So the whole is the second word listed. And when you read your book, they give you like a formula to use, and I think that's more difficult than just understanding what you're reading. Alright, that's it for 4. I'm going to go ahead and do the next given question. No, I don't have time. I'm going to set this up for you is what I want to do. I challenge you to create a two-way table, so I'm going to label these. I want cats here. I want dogs here. The yeses first, and I want the yeses to intersect there, and the no's to go there. Is that cool? So for instance, how many?
Is the 92 outside the nose? There will be 92 on the bottom. Yeah.
Right, 92 is no cat, no dog. 36 are a yes cat and a yes dog. What's the leader on the party then? So anyway, to answer the A's and the B's, you're going to have to do another column with totals. You do Venn diagrams and things too? No.
It's just like,
Random math.
yeah, it's just like real world math, like distance, rate, and time. Or
Or
like, or like one of the questions, it was like half of the people in the stands are rooting for one fan, and the other half is rooting for the other team. But then half of the red team is wearing a hat, and then half of the blue team is wearing a gray hat, and it's just like a whole bunch of practice and stuff like that.
It could be like discounted things too, like which is the cheaper option.
But that's just more like for practice. None of that's actually on exam. Or like it charges a certain amount per number. I mean per like letter for icing on a cake, but like the second time you use it, it's cheaper, and you just like calculate it.
Yeah. Wow. It's really a math class.
Yeah.
Well, paper one is math.
I'm surprised it doesn't give you the math credit. What column does it fall into?
Elective.
What should I do next? I can set up another one. What was the other even? It was
18.
2, 4. Okay, let's do it 18. Pharmaceutical companies are voluntary study of factors and actions the company claims that the medication is effective in 94% of the cases. Do the data support this claim?
Everyone. Yeah, I got 50%.
Okay, anyways. Right. Oh my gosh. Sorry. I didn't do it by my phone, and I was like, this. And she was like,
Alright, so for 18, to be effective, you need to accept medication, and there is no remaining acne. And that's just my hint.
she's trying to like try to. Why are you? Oh my god.
The FDA is like almost nobody.
It's like whenever the FBI investigates